Welcome to Water Supply and Wastewater Engineering class. So today we'll be discussing the Unit 4, that is Municipal Water Treatment Plant Design Details. That is lecture number 13, Treatment Plant Setting and Hydraulics. So this is a new unit. So up to last unit 3 we have discussed the different units which is present in the municipal water treatment plant. So starting from screenings, then you have the aeration tanks, then the primary sedimentation tank, then coagulation flocculation tank, right? Then you have the secondary sedimentation tank. After that, water will go for disinfection. So these are the different units we have discussed in details in the last unit, unit number 3. So this unit number 4 will be discussing about how exactly you place all these units in a water treatment plant, right? So now you understand the different treatment and different units are required for the entire water treatment plant. So now in a plant, sequentially one unit to another, water will go, right? So how to place all units in a water treatment plant? So some will be at the high elevation, some will be at the low elevation, right? Because we want to make the water flow by gravity, right? As much as possible, pumping we should avoid it, because pumping, if you do it, then again the cost of water treatment will increase. So how to lay down different units and all, what in what basis we will do it. So that we'll be seeing in this unit 4, that is lecture number 13, treatment of plant seating and hydraulics. So what is plant seating? So we'll be discussing now sequentially. So the treatment plant layout and seating. So the plant layout means what? Plant layout means each component. So you have now first aeration tank, then you have a primary sedimentation tank, then you have the coagulation flocculation tank, you have the secondary sedimentation tank, you have the disinfection tank, and lastly water will go. So these are different units, right? So these units will be placed sequentially in a systematic manner on a water treatment plant. So this is, we call it plant layout. So to prepare the plan of keeping all these units sequentially, that we call it layout. So plant layout is arrangement of design treatment unit on the selected site. On a selected site, how will you keep all these things one by one? That is, we call it plant layout. So, and the seating, what is the meaning of seating? Seating is the selection of site for the treatment plant based on the features such as characteristics, topography, shoreline, etc. So what we have to first, we have to select the site site of a the water treatment plant, like where we want to construct the water treatment plant, because the water will be passing from one unit to another unit, like serially water will go, right? So if you have a hilly area, right, where one side is up and another side is down, then that area is very much ideal for the water treatment plant. Why? Because all unit one by one you can keep it in a valley, so water will be simply passing from one unit to another unit by the gravity itself, so no need to pumping and all is required. So based on those type of topography structures, you can choose the location of the water treatment plant. And also it should not be very far from the shoreline, means from where we are collecting the water, the surface water if we are collecting from river or lake, so it should be very near to that. Also the topography also we have to use, right? Means up to down, like that, if any structure is there, that we should use it. So that site selection, we call it sitting. Okay, so the site development should take advantage of existing site topography, right? So such that you have to design, like this is the final unit, right? Final unit, you should not keep it at a hilltop. So in hilltop always there will be aeration tank or someone. Then gradually you will go down and one by one, and at the valley, at the downmost portion, you keep the final step, that is the disinfection. So like that, if you do, so that will save, so, must that will increase the productivity, efficiency will increase, and also the cost of water treatment also will be reduced. So the following principles are important to consider. So these are the considerations we consider for laying out the treatment plan. So a site on a side hill can facilitate gravity flow that will reduce the pumping requirement and locate normal sequence of unit without excessive excavation or fill. Right. So if that hillside is very much useful or very much important location if you get it for the water treatment plant, because in hillside you have the top portion where you keep the higher units, whereas the bottom side you keep the lower units. So that will reduce the cost of water treatment. And also, if there is no hilltop, then what will happen? Then if you have a plain land, so in that case you have to dig some portion so that the unit you can keep it at the lower elevation, so that the water flow is happening by the gravity itself. So now this is the first consideration you have to consider. Second one is the when the landscaping is utilized, it should reflect the character of the surrounding area. Site development alters the existing natural stability. Now what will happen after you treat the water? Again, water has to be distributed to the household also, right? So uh, in a city or in a town, always the slope will be there, or maybe some slope from up to down. In a city it will be there. So you have to choose the water treatment plant in such locations that natural slope you will get it while distributing the water also. So that also you have to take care while selecting the plant location. The developed site should be compatible with the existing land use and the comprehensive development plan. So like that, basically you have to choose the plan in a perfect location so that everything is fine. We can use the gravity force for flow of water from one unit plant to another unit treatment. So that's how actually we can reduce the cost of construction, and also cost of also the system will be very much efficient. So now the treatment plant hydraulic. So hydraulic profile is a graphical representation of the hydraulic grade line throughout the treatment plant. So we call it, right, if you studied in the fluid mechanics class, we call it head, total head, water head, right? So if you have a tank of water, so this is a tank of water, and if you connect a manometer somewhere, something like that, so water will go up to some certain height, right? So that height we call it water head. So always if you have a good water head at the beginning aeration tank, so at the hilltop basically, if you maintain a good water head, then the next unit will be little down, next unit will be little down, right? Next unit will be little down. So in every step, when water is passing through each unit, basically it reduces the water head. So and this profile of of reducing the water head, we call it the hydraulic profile. So hydraulic profile is a graphical representation of hydraulic gradient line throughout the treatment plant. The head loss competition are started in the direction of flow using the water surface, right, in the effluent of the first treatment unit. So how much total water loss is happening? So what is the unit water height at this point, that is the starting point of the water treatment plant, and what is the water height at this point, at the bottom point? That we call it total available head. Okay, that we call it total available head at the treatment plant is difference between the water surface elevation in the influent and the effluent, right? This difference we call it total available water head. If the total water available head is less than the head of the loss, because whenever water is passing from one treatment to another treatment, another one unit to another unit, there will be head loss. Water head loss will be there, even because water is piping going through pipes, right? And also exit entry of each unit, there will be head loss. So if head loss is more than the total available head, in that case you need to do the pumping. So pumping is required. So if head loss is available head loss is higher than the total unit total head loss, then if the available head loss is if available head is more than the head loss, then obviously water will flow by gravity. So such a system we should design where the less pumping is required, right? And if you don't have this type of terrain or this type of valley where the you don't have that much total available head, in that case you have to use the pump for transporting water from one level to another level. So in that case again cost of construction will increase. So now the principle of preparing the hydraulic profile. Now how will you make hydraulic profiles on a site? So you imagine you are a site engineer and you have given a task to design and construct a water treatment plant. So in that case you understand, you corrected the water, right? Now you know what is the treatment plant, treatment unit, right? How water is going from one treatment to another treatment. You know all these things in details now. Now how will you lay down all these things in a sequential manner? So the hydraulic profiles are prepared at the peak and the average design flow at the minimum initial flow. So hydraulic profile means that water head, as I mentioned in the last slide also. So you have to design water head should be such that it can supply the peak and average design flow. We discussed, right, what is peak water demand, average water demand. So it should take care about those parameters, right? So the available head should be such that it is not like minimal available head is there, water is going slowly. Again, we cannot meet the requirement of the city in that case. So that's why proper available head we have to ensure. If it is not available, then we have to use pump for that. The hydraulic profile is generally prepared for all the main paths of flow through the plant. So main path means one plant to another plant water is going, right? One unit to another unit. So that is the main path we call it. The head loss through the water treatment plant is the sum of head loss in the treatment unit and the connecting pipes and the other instruments, right? So water is flowing from one unit to another unit, so that's head loss is happening because friction will be happening. Water will go through pipes, so pipe friction will be there. Entry point there will be head loss of energy. Exit point there will be loss of energy. So that is the total head loss. You have to count it from starting to end. So the head loss through the treatment unit includes. So how you can check it? First one is the head loss at the effluent structure. Effluent structure means at the beginning first, like at the aeration tank where the water is coming. That is we call it effluent structure. So there you have the loss, water loss. Similarly, when water will passing, going from aeration tank to the next chamber, you will have the head loss. Next, while water is going inside the unit, then there also there will be head loss. This is the head loss through the unit. When water is passing in the unit, there also head loss will be there. And other miscellaneous and free fall surface allowance, all these things will be there. Head loss will be there. So now the total loss through the connecting pipes, channels, and other instruments are some of following. So in then even head loss due to the entrance, like water will go through a pipe. So when it is going inside the pipe, there will be entrance. In the entrance, there will be head loss. During exit of this pipe, there will be head loss. Then in some portion pipe will be narrow, some portion pipe will be wide. So contraction and enlargement, there also head loss will be there. Then there will be loss due to friction, like water will make friction to the pipe of the wall of the pipe, right? In there also you will find the friction. Head loss due to bends, right? Pipe will not go straight every time. There will be bends, there will be gates, there will be valves in the water system plant. So there also head loss will be there. Similarly, head required over the wear and other dynamics. So this is the total head loss, you can count it. And if the total head loss is more than the available total water head, then water cannot flow by gravity, then you have to use some extra pumping and all. So each unit, how much head loss is happening, how much head loss is required, all these things has to be considered, all these things has to be calculated sequentially, and ultimately we can design the each treatment plan where it will be. So aeration tank may be at the top, then gradually primary sedimentation tank, secondary sedimentation, like that, in a down profile you can make all the arrangements. So in this lecture, what you have seen is the how you can place the different units present in the water treatment plant in a sequential manner, so that the cost of production will be reduced. Because if we use the gravity force, in that case the production cost will be increased, operational cost will be decreased. So this concludes this unit number 4. So in the next lecture onwards, we'll be starting the distribution of distribution of water to the household. So now we have collected the water and we have cleaned also, and we have purified the water in the water treatment plant. Now it's time to distribute the water into the household. For that we have to lay down different pipe networks and uh, across the city or across the village, across the town, and then water has to be distributed. So in the next lecture we'll be starting this new unit number 5, that is water distribution system design. So this lecture was very small lecture. We have completed this unit 4. Thank you.